is Dr. Karnik with New Science Academy, and today's topic is chemical kinetics. We are going to go over a question which talks about predicted rate loss. Now, when it comes to these questions, the premise on which these questions are built are most of the chemical reactions are not a one-step reactions. They usually have two or more steps. These intermediate steps are also called elementary steps. Now, some of the steps are going to be slow steps and some of the steps are going to be fast. Usually when it comes to determining the rate law, the slow step, the slow intermediate step or the slow elementary step is the rate determining step. Similarly, here when you are talking about a chemical reaction, which is divided into various steps, the step which is going to be slow paced is the one which is going to determine the overall rate of the reaction. And therefore, when you're given these questions, you want to pay attention to the slow step and determine the rate law of the slow step. So let's go to a question. Now here we are seeing that this reaction AB plus C gives A plus BC is experimentally observed to be second order in AB and zero order in C. They're asking if the following mechanism is valid for this reaction, and they're giving us a two-step mechanism. In other words, they're saying that are these two steps, step 1 and step 2, intermediate steps for the overall reaction AB plus C gives A plus BC. Now, if this is true, we need to find the validity in two steps. The first step is we are going to add these intermediate steps and see whether the addition totals up to the final reaction. And for that, we are going to simply total both the reactions, put reactants on one side and products on the other side. So here I'm having AB plus AB coming from the first intermediate step plus AB2 plus C coming from the second intermediate step. And it is giving me AB2 plus A product from the first step and AB plus BC product from the second step. Then I'm going to look into the molecules on both sides of the arrow and cancel out the ones that are in common. So here I see there is one AB here. I can cancel out this AB. I'm also seeing AB2 and AB2. I can cancel those out. There is nothing else which is common, and therefore I'm going to write down the final reaction. AB plus C gives me A plus BC. I'm going to compare this equation with the equation given to me, and what I'm seeing is that both these equations are the same. Therefore, the first step is a valid step. Now comes the second step. If this intermediate step is valid, then the overall rate law is going to be the same as the rate law of the slow intermediate step. So let's first calculate the rate law of the slow intermediate step. And here I'm going to write down for this step, K is equal to reactant AB multiplied by reactant AB. As I can see here, these are the two reactants. So I'm multiplying their concentrations and I get this is equal to AB squared. This would be the rate law of the slow intermediate step. Now we want to see if this rate law is equal to the experimentally observed rate law for the overall chemical equation. So here I'm going to write down for this chemical equation, which is this. I'm seeing that it is second order in AB and zero order in C. That was the experimental observation. So based on these observations for this reaction, I can write K is equal to second order in AB, therefore AB squared, second order, and zero order in C, so to the power 0. Therefore, I know that K is equal to AB squared. And this is the experimentally observed rate law is the same as what I found in the slow elementary step. This is the second step of validity. So when I'm seeing both these steps are valid or in accordance with intermediate steps for overall chemical reaction, I will confidently say that this mechanism is valid for this reaction.